Blockchain technology as we have it today is not entirely suitable for EMR usage, where I would not want to have my lab records, I would not want to have my medical history available to everybody, and sort of means of encrypting it, means of ensuring that only those people with a need to know access it, need to be in place. So that is, blockchain can be at the heart of a sharing system like this, an EMR record like this, EMR system like this, but it needs to be amended with additional features to ensure that data doesn't get into the wrong hands.
This is Emin, a professor at Cornell University who's currently visiting EPFL. And today we're going to talk about ways to store private information on blockchains. Now, we did a few previous videos on blockchain, but for the purpose of this video, suffices to say that blockchain is a shared public database which contains a lot of information, possibly sensitive information, about its users. So how can we guarantee privacy in the blockchain?
There are a couple of interesting techniques in our tool chest here. So one of them is something called zero-knowledge proofs. So this is a fascinating result from mathematics where essentially what I can do using a zero-knowledge proof is prove a predicate, a fact, to you without revealing any of the preconditions for that fact.
Let's give an example.
For example, you'd like to know if I am over the age of 18 to buy alcohol. And the traditional way I would prove to you that I'm over the age of 18 is I show you my ID card. And you can see my name, my birth date, etc. That's entirely broken, if you ask me, because you got to find out exactly who I am, even though all you needed to know is whether I'm of age or not. If I were to use a zero-knowledge proof in this scenario, I could prove to you that I'm over the age of 18 without revealing my name, my birth date, or even my age to you. You would simply get to find out he is over the age of 18 and nothing else. And it's a magical, cute trick of mathematics, of a very nicely, cleverly constructed system that can make another party assured 100% of a particular fact without revealing the data behind that fact.
This is very cool. Zero-knowledge proofs were introduced in 1985 by Goldwasser, Micali, and Rakov and won the 1993 Gödel Prize. They allow a wonderfully clever management of privacy.
So one of the most exciting uses of zero-knowledge proofs is in financial transactions. We would all like to use these new systems for transacting electronically without being surveilled on. I would like to be able to spend my money without having anybody see where I'm spending my money, how much, with what frequency. This is a fundamental right, I believe, of any human being in general to not be surveilled upon.
Unfortunately, as we discussed it in a previous video, this is not the case for Bitcoin. Basically, with Bitcoin, all of your transactions are publicly revealed, which allows any surveillance team to track down all of your past transactions.
So zero-knowledge proofs can help here. There's a particular system called Zcash, it's a cryptocurrency, where the primitive to transfer money is based on a zero-knowledge proof. In essence, what you're saying is, I am truly in possession of some amount of money, and I'm giving it to you, okay? Without revealing where you got the money from, without revealing a trace of where the money came from to you, but you assure the other person that you do indeed possess it, and then giving him the right to spend it without identifying who he is.
This is fascinating. Roughly speaking, the trick is to first commit to an encrypted transaction. This commitment is then written in the blockchain. And later on, you would give a zero-knowledge proof that you did commit to a transaction recorded in the blockchain without revealing which one it is. Now, this is very roughly speaking, and Zcash relies on protocols which are way more sophisticated than that. Unfortunately, this also means that Zcash protocols are very hard to explain. But here's the rough takeaway.
Blockchain gives us an orderly, serialized series of transactions, but the ZKPs, the zero-knowledge proofs, hide what happened on that chain.
So let's add zero knowledge to the proof. Nothing about the witness known to the sender will be leaking to the verifier or anyone else through that proof.
If all of Venezuela were to switch to Bitcoin right now, every adult would get to transact once every 36 days.